Okay, so if you look on the next page, I have several steps listed for you. Write down the information that's given, state the null and alternative. The significance level, all three of these really are just step one. Then you need to justify which test statistic that you're using, find it, decide if you need a one-tail or two-tail test to find your p-value, find your p-value, and then make a comparison and a conclusion. So it's not as complicated as I probably make it sound. But let's look at this very first one. I have a manufacturer that claims that the average activating temperature for a sprinkler system for fire protection is at least 135 degrees. So as I read it, I start writing down things that I find. And at least is an average that's greater than or equal to 135 degrees. So we know that's the null. It's also the claim. So it's not going to give you the other one, but you can find it because it's the complementary event. So there's your ha. You want to test this claim, so you randomly select 32 systems, and you find the mean temperature to be 133 with a standard deviation of 3.3. So both of those are sample statistics, so that's why I'm using X bar and S. You're also given that your alpha level is 0.1. So this is going to be your comparison level. So basically what we do is what we've already been doing, and we find a z-score or t-score based on what's going on. We do have to make an assumption here, so we're going to assume that we have a normal distribution because the problem did not give it to us. And Ms. May is pretty bad about that, but my stat lab is not. They're very specific. Assume normal distribution. We're going to use z because n is greater than or equal to 30. I wouldn't argue with you on your project if you wanted to pick t here and say it's because sigma is unknown. I would be perfectly fine with that, but you need to make a statement about why you chose what you chose. Now, z is found by taking x bar minus mu divided by the standard deviation divided by the sample size. So when we do this, what z-score do we get? And we get negative 3.42. Now, we're going to make a p-value statement now based on the a p-value statement based on the alternative hypothesis. So the p-value is what is the probability that you would get this z-score. So p-value is equal to probability that this z-score is greater than or less than. Well, it's less than, or you wouldn't get the tail part of the picture, right? Remember, we talked about this. This is 0, 1, 2, negative 3. So you're talking about only a really teeny tiny piece way over here. If you look this up on your table, you'll find that the area is 0.0003. What this represents is the probability that you could get 32 randomly selected sprinklers have a mean of 133 if in fact the real mean was 135. So clearly this probability is teeny tiny, and so we reject the null. We reject the null because the p-value is smaller than the alpha level. Now, the alpha level is 10%. This is way smaller than 10%. But this part isn't the hard part. Usually it's making the final conclusion. And so go back and reread and answer the question asked. Do you have enough evidence to support the manufacturer's claim, which is why it's a good idea to put which one is the claim when you're writing your hypothesis test. The claim was the null, and we rejected the null. So no, not enough evidence to support the manufacturer's claim. And ta-da, look how awesome. We just ran our first hypothesis test. Now, in 7.1, you have an overview of the actual process. 7.2 does population means when sigma is known. 7.3 does population means when sigma is unknown. So both of these are the same process as what you just saw. 7.4 is proportions. All right? So I think you're in good shape to get started. You ought to be able to do 7.1 through 7.3. In the next video, I'm going to show you how you can use StatCrunch to help you out a little bit, and also check your answers. Please don't use it to do everything, or you will cheat yourself in understanding the process. Have a great day.